guys, my name is Nako Nakatsuka. I'm a fourth year chemistry PhD student at UCLA, and today I'll be helping you guys out by going over some general chemistry concepts. And good luck with the course. Now let's try an actual problem that utilizes the different concepts that I just talked about. So this question asks, at what temperature is bromine going from liquid to bromine going to a gas spontaneous at 1 atmosphere, so at constant pressure, given the delta H and delta S at standard states. So when something is spontaneous, we have to figure out when is delta G negative, right? And so let's write out the equation. Delta G naught is delta H naught minus T delta S standard state. And looking at the values that were just given to us, delta H is positive and delta S is also positive. So this being positive indicates to us that it's an endothermic process, right? If it was negative, it would be exothermic. So this does not favor the forward process. But since delta S is positive, the reaction does favor the forward process. So this means, going back to the table that we looked at before, that this reaction will be favored when the temperature is high. So favored at high temperatures. Okay, so in order to figure this out, the exact temperature at which it's spontaneous, we have to do some calculations. So first, we can find the minimum temperature by solving for when delta G is 0. And at this point, Br2, as a liquid, is going to be in equilibrium with the bromine as a gas. So now let's set up the equation as 0 equals delta H minus T delta S. And then let's rearrange it so that it becomes T delta S equals delta H naught. Because then we can solve for temperature, right? Temperature is delta H over delta S, which are values that are given. Just make sure you always make the units equal to one another. So this would be 31, but let's make it joules because the delta S is in joules. So this will be 31 times 10 to the power of 3 joules per mole, divided by 93 joules per Kelvin mole. So now looking at these units too, the moles cancel out, the joules cancel out, and we end up with a value in kelvins, which is good because we want temperature. And the value ends up being 333 Kelvin. So what this means is that at a temperature of 333 Kelvin, the liquid and the gaseous form coexist. This is basically the boiling point. But then at any temperature above 333 Kelvin, the forward process is favored and the gas phase dominates. And that means that the delta S, or the entropy value, is going to dominate. On the other hand, when the temperature is less than 333 Kelvin, then the reverse process is favored. So we would end up with more of the liquid phase, and the delta H term is going to dominate. So in this case, for the answer to this problem that says at what temperature is this going to be spontaneous, the answer is at any temperature above 333 Kelvin. Because at 333 Kelvin, both of these will coexist. It's at equilibrium, but as soon as you shift the temperature to slightly higher, you're going to end up with a spontaneous process.